All right, we're going to discuss hyperbolic trig functions. And it's an interesting concept because you are used to learning about trig functions and trig ratios as based on the unit circle, whereas hyperbolic trig functions are based on what we call the unit hyperbola. And the unit hyperbola has this equation, x squared minus y squared equals 1. So if you think about back when you learned how to graph a hyperbola, this box here that you would have had that kind of connects the vertices and the slant asymptotes go through the corners of the box. This box would have each side as 1 in a unit hyperbola. So basically, the hyperbolic trig functions are created by using this area here. So what we're going to do, let me scroll down and I can show you. Hyperbolic cosine, first of all, is notated cosine h, and hyperbolic sine is sine h. So on this image, the point cosine HA and sine HA is this point right here, and it is the point where the value A, this value A and this value A, is twice the area bound by the x-axis, the unit hyperbola, and the ray that originates at the origin and goes through the point cosine HA, sine HA. So it's an intriguing concept that this is a value here, really an x value, an input value, okay, which here's our input value, that when we input it, we create an area here that is half of that value A. So that is where we come up with hyperbolic sine and hyperbolic cosine. The rest of the trig functions will be derived from those. Of course, hyperbolic tangent would be hyperbolic sine over hyperbolic cosine, just as if tangent would be sine over cosine. And then you can get the reciprocal trig functions as well. So we can also write hyperbolic trig functions in terms of e to the x. To do that, let me erase that. To do that, you basically have cosine hx, hyperbolic cosine, is e to the x plus e to the negative x over 2, whereas hyperbolic sine of x is e to the x minus e to the negative x over 2. And then, of course, you can create tangent is going to be as follows: sine over cosine, hyperbolic sine over hyperbolic cosine. So e to the x minus e to the negative x over 2, and then instead of dividing by the hyperbolic cosine, we'll go ahead and multiply by its reciprocal. So you'll have 2 e to the x plus e to the negative x here, and then you're going to go ahead and cancel out the 2's, and you'll be left with e to the x minus e to the negative x, all divided by e to the x plus e to the negative x. Then if you're going to do hyperbolic cotangent, you could just take the reciprocal of hyperbolic tangent. So e to the x plus e to the negative x divided by e to the x minus e to the negative x. And then to get hyperbolic secant and hyperbolic cosecant, we're just going to take reciprocals, the reciprocal of hyperbolic cosine to get hyperbolic secant. It's 2 over e to the x plus e to the negative x. And then hyperbolic cosecant is the reciprocal of hyperbolic sine, so 2 over e to the x minus e to the negative x. And my computer's talking to me as we do this. All right, so that is basically the concept of hyperbolic sine and hyperbolic cosine. The next page, and there are other trig functions that are driven by them. The next page, we talk about differentiation. So the derivative of cosine hx is really just negative sine hx, which is exactly as you would expect since regular cosine differentiates to negative sine, and then sine differentiates to positive cosine, so hyperbolic sine differentiates to hyperbolic cosine. And then just like with tangent going to secant squared, hyperbolic tangent goes to hyperbolic secant squared. And last, secant, which typically goes to secant times tangent, hyperbolic secant goes to hyperbolic secant of x, times hyperbolic tangent of x. So these all look very familiar because they follow this pattern as the typical cosine and sine and tangent and secant differentiations. Okay, so let's do 4 examples. They're fairly straightforward examples. First, to take f prime, we have sine h going to cosine h of x, and then cosine goes to negative sine, so we'll have negative 2 sine h of x, and then secant goes to secant times tangent, so secant h of x times tangent h of x. Second one, getting a little trickier since I have a product rule built in. F prime equals tangent h goes to secant squared h of x, and then my product rule, I'm going to leave x squared alone, and I'm going to differentiate cosine to negative sine h of x, and then I will differentiate x squared to 2x and leave alone cosine h of x. That's a basic product rule with hyperbolic trig functions. Now we're going to do a quotient rule where I have low d high, so tangent h of x stays by itself. The derivative of x plus 1 is itself, and then I'm going to leave x plus 1 alone and differentiate hyperbolic tangent to hyperbolic secant squared. And then in my denominator, I will have the hyperbolic tangent squared of x. And then last but not least, f prime here, I have a product rule. E to the x goes to itself when you differentiate, leaving cosine h intact, and then e to the x when it differentiates, well, I've already differentiated. E to the x, leave alone, and differentiate cosine h going to negative sine h of x. And that's really all you need to know about the hyperbolic trig functions and basic differentiation techniques of them.